Right, so today what we're actually going to be doing is the 2011 higher level question, the road geometry. And starting off, always reading the question fully and then work your way along the question. So it says at the very top here, the accompanying map shows ground contours at 5 meter vertical intervals. Our scale we know actually is 1:1000. So straight away up here in the space provided, I'm actually going to put in, just usually I say to my students, a magic number when it's 5 meter vertical intervals between the contours, 60 here, 55 here, we know it's 5 meters. My scale is 1:1000, my magic number is going to be 5. Okay, now part A. A, B, C, D is the centre line of a proposed roadway. A, B, C, D. O is the centre of a circular curve, so where the road curves here from B to C, we can see that O is the centre of it, and the roadway has the following specifications. The section of the roadway between A and B is level at an altitude of 70 metres, so straight away there at A I'm just going to write in 70, B is also 70. The section from B and C is also level at an altitude of 70, so C actually is also at 70. And is curved as shown. The section from C to D has a gradient of 1:15 falling. So that means from C to D the road is actually dropping. So I'm just going to say gradient here. Gradient 1:15 falling. There we go. I always find it just helpful to write this stuff down on my sheet as I'm kind of going along, just in case I was getting confused having to look back up here for it. And it says using side slopes of 1:1.5 for cuts. Okay, so in the space provided here at the top, writing down my cut. So for my cut triangle or my cut ratio, it's 1:1.5. So I'm going to put in my cut one there, my fill one here, or my embankments as they say. Now for my cut ratio it says it is 1:1.5, and for my fill ratio it is saying and 1:1.2 for embankments, so that means 1 there, 2 here. So for every 1 meter I travel down vertically, I'm going to go out 1.5 horizontally for cuts, 1 meter down vertically for fills, which we don't see in plan, but we travel out 2 meters for in horizontal. Now, if we apply that with our magic number 5, that means when I'm doing my cut lines, 5 times 1.5 is going to be 7.5, and for my fill, 5 times 2 is going to be 10. So nice and set up there, and it says complete the artworks necessary to accommodate the roadway on its northern side. Note the southern side has already been completed for you, so this bottom section down here is already done. So starting off here, we're going to stick with the easy part of the road, and we're going to do from A to B to C, because all of that is level and it's all at an altitude of 70, and it's just looking at the contours around it and determining whether we need to cut or fill up in this section. So starting off here, I'm going to start with A to B, and then I'll get on the curve part from B to C, and we'll work with this bit afterwards. So it's just a case of working out what I'm actually going to have to do. So road is at 70 from A to B. So I'm looking at the contours that are actually around it. If I look up here, it says 65, 60, 55. Down here then it goes 50, 50, 55, 60, 65, 70. So that's actually a point on the road straight away right there, like it is down here. So in this section all along here, the road is actually higher than it and the land is lower, so I'm going to have to fill. And for all my fill measurements out, I'm going to do a measurement of 10. And when we're measuring out, I'm going to measure out in measurements of 10, but I'm actually going to measure out every 10 is going to be 5 meters down vertically. So it's going to go 70 here at the side of the road, 65, 60 and so on. And I think my lowest one actually is going to be down as far as the 50, so I'm going to need about 4 of them. So from here, measuring out 10, 20, so it'll be 65, 60, 55, 50. So from here, just know how far I have to go. Putting in my little steps at the side then, if the road was here was at 70, Then when we're filling, it's going to go down from the road 65, 60, 55, 50. And I think 50 was as far as it went. So it's a case now of just plotting our points. So we had 70 here, then the next one was at 65, so there's a point 65, 60, 55, 50, and we have 50 again. Yeah. Then I go back to 55, and 60 would have been over here somewhere, so I can imagine it's continuing on over there like that. So right now straight away, I'm going to put this in light enough. I'll go back over it heavy in a while. Keep it neat and tidy. And if I'm measuring the 61 was going to be down here somewhere, so I'm going to continue it down over there like that. Okay, I know that can actually be heavied in, because there's nothing else that is going to happen after that, so nice dark line. There we go. And now what I'm actually going to put in is my tadpoles. And my tadpoles are when, if you imagine we have a ball and it is either going to roll towards the road if it's cut, and it's going to roll away from the road when it's a fill. In this case it's a fill, so if I put my ball here at the side of the road, he is going to tadpole down. That's why we call them tadpoles, just because they look like tadpoles in the water. A head with a little tail. So every one of them balls is rolling away. That's our fill part of the road. Now, if we look down here, we have 70, 75, 80, 85, 85, 80, 75, back to 70. So straight away, once again, I can locate a point on the road where altitude was at 70. And in this case, the land around it is higher than the road. So in this case, we are going to cut. And we worked out our cut ratio a while ago to be 7.5. So, I'm going to measure out in 7.5. Let's just work out how many I'm going to need. 1, 2, 3. I'm going to have to go up 3 times of 7.5 increments. So, 7.5 plus 7.5 will be 15, plus 7.5 is 22.5. And 3 measurements right there. Once again, right in my guide, so the road here was at 70, and this time when we're doing cuts, it's actually going to rise. So this one is going to be 75, this one's going to be 80, and this one's going to be 85. That's as far as I needed. So once again, plot our points. 70, this one was at 75, then we had 80, 85, I think it's 85 again, yes, and we're back down to 80, and our 75, and back to our 70. So same thing, nice light line. Keep it neat and tidy, get your curve in first, go over it afterwards. And this time, when we're putting in our tadpoles, it is actually going to be a ball rolling towards the road. Because the land around the road was higher. Okay, next part here, we're getting onto the curve part. We're throwing in a little bit of a trick at us here, but it's almost the exact same thing, only we're just going to follow the curvature of the road, and we're going to use the center point here to guide us with our kind of contour lines. It's just a case, once again, we have to work out, is it a cut or is it a fill? And straight away, we actually have 2 points on that road again, where the 70 contours are actually passing through it, which is right here and here. And in this case then, we're going to have another, both these contours are at 65, so I can see when the land around it is in between the 70 and the 70 is actually lower, it's 65 here and 65 here. When it's lower than the road, we're going to do a fill. And I actually only need one of them, and for fill we're going to do a measurement of 10. So, just going to get my compass here, get set up. And we will measure out a measurement of 10 millimeters. from the side of the road. So there's my 10, marked it there, take my compass from O, there we go, nice and simple. And what I'm going to do now is plot my points, because that contour line was at a height of 65, because the road is at 70, this one's at 65. Plot my 2 points, which is here and here, and away we go. Touching the road here at 70, nice and simple. Once again, just go over it. Done. And in this case, it was once again, it was a fill, so the ball is going to roll away from the road. Okay, first part of the question almost done. We just have to complete the artworks up here, and this is where it just gets a tiny touch, a little bit trickier. So if we actually remember to the question, looking back up here, the section from C to D said it has a gradient of 1 in 15 falling, which I have written in already, gradient here 1 in 15 falling. We're actually going to have to use a little bit, and I'm going to zoom in on this part now so people can see it a little bit better. Okay, there we go. Now, on this section of the question, well, it doesn't actually give us an exact height here for D. If it did, we'd be able to work out the slope and how much it was rising and the difference between C and D. If it was D was maybe at 80 if the road was rising, or in this case, sorry, falling, so if it was 70 here it might be 60. We just don't know. It doesn't give us an exact height. So what we're going to have to do is we're going to have to pick a point on this road using this ratio here, 1 in 15 falling, and we're going to pick a point on this road to get an exact height from. And to be able to do that, we're just going to use the ratio to guide us. So I often just draw a triangle here, and in this case C is actually the higher part of my road, so I'll put C here on the left, and I won't call it D because it isn't that D, but what I will call it is X. So let's say X is the point we're trying to find, and then this part here, which is C, is at an altitude of 70, and for every 1 meter we drop down we go out 15 basically. Now it's a case of using that to our advantage. I'm always going to try and get out in measurements of, since we have 5s here on our contours, we can go out in 5s or 10s or so forth, and it's a case of working with what length of the road we have and trying to think of a 15 and what that divides into evenly. So between C and D I have a distance there roughly of 105, maybe, I think it is, about 105. So if I was to multiply that by 10, say, that would be 150. That's not going to work, because grand, I'd be going down 10 meters in altitude, so I'd be dropping from 70 to 60. I'd have to go out 150 meters, or 100 in reality, but on my page that would be 150 millimeters. So what I'm actually going to do is I'm going to drop down, because 150 millimeters actually goes off my page there, so it won't work in this case. So what I'm actually going to have to do is work out a different scale. So I'm going to actually pick something half of that. So in this case I want to drop down 5 meters in altitude. So if that's at 70 take 5, so X is going to be 65 for me. And 5 times 15 is actually going to be 75. So I'm going to measure out there 75 from C, 75 millimeters, or 75 meters in reality, along my road, and that point there I'm going to label X, and X is going to be at an altitude of 65. There is a determined point on my road using that gradient 1 in 15 falling. Now, next part of the question, we are going to have to determine whether we're going to need to cut here or fill. So looking at this, 70 to 65, and if we look at the contours, this one's at 70, next contour here is at 75, 80, 85, 90. We can see that the land around it is higher, so we're going to actually have to cut. And the thing is, when you're on a road that is either falling or rising and you have to cut or fill, you just need to remember when it is a cut road, the cut cone is based off the low part of the road. So it's not going to be based here at 70, it's actually going to be based at 65. However, when it is a fill, it is going to be based off the cone, the fill cone is going to be based always off the higher part of the road in this case, or in another case that would be 70. But because in this section here we're going cutting, we're going to do our cone off the lower part of the road. So, what I'm going to do there now is just a little bit of sliding set squares. So, setting this up. Rotate it about. I'm going to do all my measurements off this line as well. It's nice and handy, because I've got a perpendicular angle there to measure from. And at this point here, I'm going to do my cut cone. But what we have to work out is the measurement. So my cut cone in this case, we know when we're cutting, our ratio is 1.5. And what we have to determine is the height difference in the gradient drop. So at C it's at 70, and at X it is 65. So 70 takes 65 is 5. 5 times our cut ratio is 1.5. So 5 multiplied by 1.5. That means we're going to have a cut cone of 7.5 millimeters. Or in reality, that would be 75 meters, I think it is. Or 7.5 meters, I apologize. So, once again, get my compass. I'm going to measure out along that. It's a bit of an awkward one to draw. 7.5. And from there, I'm going to do my cut cone. As best you can, as long as you can get the arc. Probably manage. There we go. Now, from where C came straight up to the road, looks like I have a point there roughly. I'm going to do my tangent. And then, what we have to determine is what is the height of that. So just getting back to that, just determining the height of that. Wherever the tangent is coming from, and it was coming from C, which is at a height of 70, or an altitude of 70, it keeps saying height, that means that this tangent is at 70. And we know that around the land that we are going to be cutting. And for our cut ratio, we have a measurement of 7.5. So from there, I'm going to measure out measurements of 7.5. And just to do that, yep, 7.5. Measure off the side of this so I can get accurate measurements. So 7.5, 7.5, I'm going to go 4 times, we'll see how that works out. So 5, 7.5, 15, 7.5, 15. There we go. Now, sliding set squares. So, if that one was 70, this one is going to be 75 when we're cutting. This one's going to be at 80. This one's going to be at 85. And this one's going to be at 90. May not need all of them, we'll see. We can see it actually goes up to 95. I'm not sure if I'm going to need that. So this one is going to be at 75, 80, 85, and gone up in here into 90. That's just going to be my guide. Okay, so start to complete this part. So where it was on the 70, this one was at 75, and there's 75 right here. Next one was at 80, yep. Next one was at 85, and we can see that our 90 contour has gone up here. I can imagine it would have been up there. So, just that's that one complete now. Part A done. It's just a case of having it in. There we go. Just heavy that guy in. There we go. And once again, this is a cut. So tadpole or ball rolling towards the road. Now, just the part B of that question. It says on the map E, F and G are outcrop points on the top surface of the stratum of ore, and E is at an altitude, if we follow the contour, it's actually at 65. F is at an altitude of 80, and G is at an altitude of 70. And they are outcrop points on the top surface of the stratum of ore, so they are actually on the head wall. When it is, they say the top surface, they always mean it is the head wall. It says complete the given construction to determine the strike line, so which is always going to be in plan, which we have here. For the stratum, and determine the dip of the stratum, so we want to get the inclination of that head wall ore, so we do. Now, what they haven't done here, and there's two ways you could do it, and David actually broken it up nice for us here. It's just whether or not you could actually recognize this. If we have the plan, we could always get the elevation of it. It would be somewhere up here, so we could set up an XY line, so we could, and we could bring up F, we could bring up E, and we could bring up G. And we know E is at a height of 65, F is at a height of 80, and G is at a height of 70. So when I set up my XY line, I could start the XY line as a datum line, maybe on something like, I don't know, 55, and then that means I would be measuring for E, I'd only be measuring up 10. For F, I would be measuring up 80, take 55, 25, and for G, I would be measuring up 15. And I would get another plane surface up here, corresponding with it. And just relating back to something I showed on a previous question, just looking here, we can see here we have, and we want to get this line down here, which is the true length of the strike. And how you get the true length of the strike is when you do a line from the middle point in your elevation, which in this case was our A in the explanation that I have here, and we did a level line that is parallel with one of the principal planes. So the XY line here is parallel with this line here running across. And when you have a parallel line in one plane, it means wherever that line is in the opposite view, it is going to be a true length. So where it hit here, we drop it down and we'll join that back to A. That is the true length of our strike, which is basically what we're trying to prove down here, and we want to get that. Now there is another way you could do this, and it's a case of just recognizing the heights of our outcrop points. E is at 65, G is at 70, and F is at 80. So the difference between the lowest and the highest is 80 take 65 is 15. And on this line here, we can see G is our middle point. So we want to get a strike line going across somewhere like that. It's just a case of working out where it is. So we want to point along this line that is at an altitude of 70. And it's a case of working that out. And can be quite easy because it's just a case of E is 65, F is at 80, and it's a case then of determining what heights are in between. So what I'm actually going to do is 80 takes 65, there's 15 in between it, and nice round number in between 15, divided it into 3 parts, because 65, I could go 65, 70, 75, 80. So what I've done, or what they have done for us, is they've done a line, they've done sliding set squares and split the line up into 3 equal parts. Division of lines, essentially. Something you would have learnt in first year. So from this point, joined it back to the line, did sliding set squares, did equal measurements out here. That means that at this point here, if that's 65, this is actually going to be, just get a different pen, 70, 75, and then this means 80. So what I can actually determine then is, because we needed a level line that was at the same altitude in our elevation, I needed to determine the true length. And if that's at 70 at G, and this is 70 here, that is actually the true length of my strike. Some marks for that, and all it was a case of understanding. So that is the true length of my strike. Now the next part is actually quite simple, because we know to get the dip we have to look out along our strike, because we need to see the strike as a point in view. So looking out along the strike, I'll look out along there, do the same with F, and do the same with E. And then perpendicular to that I'm going to set up an X1, Y1. And there is my X1, Y1. Nice and simple. Now, you might ask yourself, how am I going to get the heights over here when I don't have an elevation? Because if you project an X1, Y1 from the plan, you take your heights from the elevation. We don't have the elevation drawn, but what we do already have is the heights that are set here. And this is like what I said previously, of setting it up if I wanted to do it up here earlier, which was another way. So we know E is at 65, F is at 80, and G is at 70. So one way I could do this is very simple. I'm going to take the X1, Y1 that is already at an easy enough height. I'm going to imagine it's at 60. That means to find E, 65 takes 60, just have to measure up 5. So that would be my E1. 70 takes 60 is 10. So for G, I'm going to measure up 10. And F, 80 takes 60 is 20. There's my F. Locate all 3 points, label them. So there's my F1, G1, E1. And if I am accurate, every one of them should join up, and they seem to do it here. And what I've actually found there is the dip. And to find the dip, very simple, you could extend this out, extend this out, and what I found inside in here is my dip. Question done.